So pretty much what a slope field is a graphical general solution. Okay. So differential equations are derivative equations, right? So what it is pretty much a visual for that. It's a visual for the differential equations. Okay, so when we're talking about differential equations, we're talking about derivatives. And when we're talking about derivatives, we're talking about slopes. We're talking about slopes. Okay, so what a slope field does is it gives us a visual. Okay, the differential equation is the equation, right? The visual is the slope field. Okay, and they're really not hard to do. And the nice thing about slope fields is they're almost always on free response for tests, AP tests and tests in this class. They're almost always a slope field question on there, and they're not very hard. They're not very hard. There's not a lot of calculations that go into slope fields. Okay, so it's one of the nice things about this chapter. Okay, so what we're going to do is we're going to make a slope field on this graph here. Okay, so what we're going to do, the first thing I'm going to show you is we're going to do a slope field for this guy right here. That guy right here. Okay, that's our differential equation. dy over dx equals 2y. So instead of putting dy's on one side, putting dx's on the other side, we're going to do a slope field. It's the same thing, except one is visual and one is analytical, one is algebraic. Okay, so it's essentially the same thing we've been doing the last couple days. Okay, okay, so with the slope field, so usually we start, and you could start anywhere you want. We're gonna put markings on. We're gonna create a field of markings. And those markings are gonna represent slopes. For example, let's start at 0, 0. Okay, we're gonna start at 0, 0 right here. Okay, at 0, 0, what would the slope of the function be? So if I wanted to know what the slope of a function was, what would I do? Like if you wanted to know the slope of a function at a certain point, 0, 0. What would you do? Plug it into which equation? You're right, plug it into the equation. Which equation would I plug it into? The derivative equation, right? We've done that since September. I think we've been doing that since September, right? That's not anything new. That's what we're going to do today. So 0, 0. So I have a point at 0, 0. I'm going to plug it into the derivative equation, which is also known as the differential equation, right? So for this guy here, it's this guy here. Okay? So what I'm going to do here is I'm going to plug in for dy dx at 0, 0. I'm going to plug in 0 for x and 0 for y. Well, what's missing here? What's missing in the equation? X. So I can't plug in x. So the only thing I plug in is y. So 2 times 0 for y, I get regular 2. Regular 2. Oh, not 2. I get 0. Sorry. All right? So that means the slope at 0, 0 is going to be a slope of 0. What does a slope of 0 look like? With your hands, with your arms, show me what a slope of 0 looks like. What does a slope of 0 look like? What does a slope of 0 look like? Yep, side to side, right? So we're going to draw a little segment that looks exactly like that at 0, 0. Okay, so at 0, 0, we're going to draw a little segment that looks like that. That shows me at 0, 0, the slope is 0. Okay. Let's move over one. Let's go to 1, 0. Let's go to 1, 0. Okay, I'm going to do the same thing. dy over dx for 1 comma 0. Again, I don't have an x. If I did, I would plug it in. I have a y though, so I'm going to plug in my y, which is 0 again. So I get 0 as an answer. So that means at 1, 0, I have a slope of 0. Now here's the thing with slope fields. I have a lot of dots to do. 5 times 5, I have 25 dots to do. I don't want to have to do calculations for 25, all 25. I want to look for shortcuts. So is there shortcuts I can do for this? Does anyone see a shortcut I can do for this guy here? Is there a shortcut where I can fill in some without having to do any calculations? Mm-hmm. Yeah, there's only y in it, right? So when is my slope going to be 0, like it was for 0, 0, and 1, 0? When what's 0? When y is 0. So everywhere that y is 0, it's going to have the same slope, right? Okay, where is y 0? Here, here, and here. Okay. Got 5 of them out of the way. Okay. So now, let's go up one. Let's go up one. Let's go up to this guy right here. Okay. That is 0, 1. 0, 1. So now I don't have a slope of 0 for y, or sorry, 0 for y. I have a 1 for y. So that's positive 2, right? Okay. So now I have to draw a slope of positive 2 at this point here. So do the best you can. Okay. So a slope of 0 looks like this. A slope of 1 means up 1 over 1. So that would kind of look like that, right? So it's going to have a little bit more. So kind of what I do is kind of picture in my head. Okay, so a slope of 2 means I go up 2 over 1. So that's where I need to aim. So mine is going to kind of look like that. Okay, do the best you can because it's just, since it's a little tiny segment, you're just doing the best you can with that. A little bit more than 1 and positive. That's all I'm looking for. Okay. Is there anywhere else on the field where it would have the same slope? When y is equal to 1, it's always going to have the same slope, right? So where else is y is equal to 1? Right under, let's see, y is equal to 1. This whole row, right? This whole row, this whole row here, y is equal to 1, right? So it's going to have the same slope. So they're all going to be parallel to each other. Oops, that one's a little too. Okay. All right, let's go up one. Let's go up 1, dy dx. Let's look at 0, comma 2. I have a slope of 4. So now a steeper slope, okay? So a slope of 4 means up 4 over 1. So a slope of 4 is 1, 2, 3, 4 over 1. So that one's going to be pretty steep. Okay, so we're going to have some pretty steep slopes all along here, right? Now, when I look at this, do I have to know that's a slope of 4? No. But what I have to look at is say, oh, okay, so This one is 0. This one increases, and then the top increases even more, right? So comparatively speaking, I have to know when I'm looking at it which one has a steeper slope, but I don't have to know exactly by looking at it. Like when I'm grading this here, I don't have to know this one right here is 2, and this one right here is 4. What I'm looking for when I grade it is this one steeper than this one. That's what I'm looking for. If it is, then I'm good. Doesn't need to be perfect. Okay? All right, let's go one row down. So let's go to below the x-axis. Below the x-axis. So let's go 0, -1. dy over dx at 0, -1. So I plug in a -1 and I get a -2. So I'm going to have a -2. -2 means down 2 over 1. So here, down 2 would be down 2 over 1. So I'm trying to aim right there. So kind of something like that. Oh, there you go. Okay. Where else would I have a slope of -2 for this guy here? Where else? Is there anywhere else I would have a slope of -2 so I don't have to do any more calculations? The less amount of calculations I have to do is nice because I could fill in this chart. Exactly, the same y row. The same y row is going to have the same exact slope. So all of these slopes should be parallel. Last row, dy over dx for 0, -2. That's a slope of -4. Okay, so -4 is going to be pretty steep. You're done. You're done. Okay, that's the slope field. That's how you create a slope field. Now, what do we do with it? How do we read it? Well, a slope field is a direction field. It tells you what direction to go, right? So let's say we're at this point here. Let's say I'm at this point right here, right? Which way would I go if I'm moving to the right? So if I'm moving to the right, which way would I go? Which way is it telling me to go? Which way is the directions telling me to go? So if I'm moving to the right, which way, if I go with the flow, which way is the directions telling me to go? Down, right, up, down, right? Graphs move from right to left. So if I'm right here and I want to go this way, which way are the directions telling me to go? Telling me to go up, right? This guy right here is telling me to go up, and then this guy's telling me to go up. So the graph's going to look something like that. Okay? That's what we're going to do for the next part. Suppose that you know the point is at 0, 1. 0, -1. So just like yesterday and the last 2 days, remember they would always give us a point, right? They would always say this point. The same thing. They're going to do the same thing. So this point here is at 0, -1. Okay? Follow the slopes to draw what's going on here. Well, as I move to the right, it's telling me to go down. The slope's telling me to go down, and I'm going to go down this way. As I go to the right, they're telling me to go this way. And then coming from this side, kind of looks like that. If I go with the flow, they say just go with the flow. Where are the directions telling you to go, right? I can't do this. I can't do this because then I'm going against these guys up here, right? So coming this way, it was 0 slope. And then as I come this way, it's a negative going downhill. Okay? So that's what the particular solution would look like. So that's what we've been doing. We've been calculating this pink guy just with algebra instead of graphically. That's what it's going to look like. Okay? So part C says, okay, so part C, let's actually do what we've been doing. Okay, let's do what we've been doing. Separate the variables and solve that way. That's what part C says. So for part C, let's solve it the way we've been solving it. Y is on the left, X is on the right. So we get 1 over 2y dy equals dx. Okay. What was our next step? What did it say to do after we separated the variables? Huh? Antiderivative. Yep, integral. Okay, over here, I just have a 1 in front. So I have a x plus c. Over here, I'm going to have to use u substitution. So I'm going to use that as my u. So u equals 2y, du equals 2 dy. 1/2 du equals dy. Okay. So I have 1/2, and then I have 1 over u du. The antiderivative of 1 over u is just natural log. So it's 1/2 natural log of u. Okay. Plug in u back in. U is 2y. Plug in my point. My point is 0, -1. So I plug in -1 for y and 0 for x. 1/2 natural log of +2 equals c, because 0 plus c is 0. Okay. So this guy is going to be 1/2 natural log of 2y plus x, equals x plus 1/2 natural log of 2. Okay. Last step, solve for y. So what I'm going to do is I'm going to multiply both sides by 1/2, or sorry, 2 over 1. So I get the natural log of 2y equals 2 x plus 1/2 natural log of 2. Just like we did yesterday, to get rid of the natural log, to separate the natural log from the y, I have to separate this from this. We're going to use exponential, so e. Right? E is the base, so that becomes the base. This becomes the power equal to that. And the last step is divide by 2. I'm going a little quick here because we've spent the last 2 days doing this, so I want to get to the new part. But like I said, that's why I record the lessons. I record the lessons so you can watch them later. So if you're like, whoa, that was too fast. Well, guess what? You can go watch it back again. You can slow it down and pause it. Okay. Let's see, -1/2, -1/2, -1/2.
You don't do anything wrong, but the y value is -1. The e can't be a negative number.
Let's see.
There was a question like that on your phone.
Oh, was there?
Yeah.
Let's see. That's a good question. Yeah, let me look it up. Let me look it up and see what's going on here. Let's see. Let me look at my notes. Thank you. Let's see. Yeah, you're right. It would be negative. Yeah, it would be negative e. It would be. Let's see. So it would be negative in front. Okay. Yeah, I guess because of the, yeah, you're right, because of the this guy right here when I plugged in negative. Okay. Okay, so my point is, that's the way we did it the last 2 days. This says the exact same thing, but this is the visual. This is what the graph is. So if you were to put this in your graphing calculator or Desmos, if you were to put this equation in there, guess what the picture would show? That pink graph there. That's what it would show, that pink graph. Okay? So we're doing the same exact thing. One is just visual, and one is through algebra, through finding antiderivatives, through isolating variable. So it's essentially the same thing. Okay? Okay, so what I want you to do now for the next example is I want you to do letter A. I want you to do letter A and B. You could do B because we've been doing B. So for letter B, I want you to give me the slope for each of those dots. So on this one, you only have 12 dots. There's only 12 dots. So I want you to give me the slope for each of those dots. Okay? I'll give you about 5-10 minutes to do A and B. Okay, see what we get. Your everything along the x-axis should all be up and down. That one, there's no question because everything on the x-axis, if x is 0, or sorry, if y is 0, it's going to be undefined, right? Okay. So what I'm looking for here is these guys are negative. This guy is a little steeper negative than this guy. Same thing here. okay? Or these guys are about parallel. These two are 0. This guy is got a positive. This guy is positive, but not as positive as this guy. Okay? Comparison. That's what I'm looking for when you're doing a slope field. Okay? I don't need to know that this is a +1 or a +2 or a +1.5 or whatever. I don't need to know that. I just need to know that this one has a steeper slope than this guy here. Okay? That's all I need to know. Okay? And then part B. Part B is what we've been doing. Part B is separation of variables, solving. So if you separated the variables, integrated, solve for C, and then solve for Y, you would get this guy here. Okay? So this guy right here is represented if I did this. So the point is right here, right? 0, 1. 0, -1. So 0, -1 is not even on the graph. 0, -1 would be down here somewhere. So if I was to go with the flow here, it would look kind of like that. Okay. I don't know whether they picked the point that's not on the graph. They should have picked a point as 0, -1, yeah. That's the first time I've ever seen one where they picked a point where it's not on the graph. They'll always pick a point and it should be on the graph. I don't know why they picked that one. Oh well. Okay, so here we go. Now matching. Matching here. Okay, so the back is just matching. We're going to match. So the first two, I give you 2. Example number 1, example number 2. And I give you 8 different options. You're only going to use these options once. Well, you're only going to use 2 of them once, and then the rest you won't use at all. So which slope field matches with these guys here? Now, these guys aren't the derivative graph, right? Look at these guys. These guys are not derivatives, right? So we can't use these guys. So if I wanted to make a slope field for this guy here, I would have to find the derivative of that guy to make a slope field, right? So the derivative of this guy would just be 0. So everywhere on the graph would have those, right? If I wanted to find this guy, I would have to find the derivative of that guy, right? So on and so forth. Okay? So let's look at number 1. So it's looking like this slope field. If I were to start over here and work my way to the right, it looks like here I'm going down and then going up and then going down like that. It looks like the derivative would go like that. What graph does that look like? What graph does that, couple of graphs does that look like? It looks like sine and cosine, yeah. Looks like it could be the sine graph or cosine graph, right? And if I look at 0, it looks like I start up and then go down, right? So which one of those starts up and goes down? Sine or cosine? Sine, right? Cosine starts up and goes down, right? Cosine starts up here and then goes down. Sine starts by increasing first. So it looks like this graph right here is sine graph. So does that mean my answer is F? Does that mean F is my answer? No, F is not my answer. I'm looking for the one that's derivative is sine. If I were to find the derivative of one of these guys and graph it, it would look like that. So which one's going to be the answer there? Letter G, yeah. Letter G is actually the answer. Okay. We'll do the next one together. And then the last page, I'll let you guys do on your own. Okay, so this guy here. So if I start over here, it looks like I'm increasing and then slowly going like that. Wait. Kind of doing that thing, right? If I went with the flow, go with the flow, right? If I went with the flow of the lines, it looks like very steep here, very steep, and then it starts to turn a little bit over here, and then here I have a flat, and then here I go up like that, right? Which graph is that? What graph is that? What kind of graph is that? What graph is that one there? Starts with a C. It's not a trig function. Yep, cubic. It's a cubic. Cubics are anything to the third power. Anything to the third power. What quadratics look like that? Cubics look like that. Okay. So we're looking for something. So this graph looks like it's graphing this guy here. All right. It looks like a cubic here. So does that mean this is my answer over here? This is a cubic here. Does that mean D is my answer? No, because D is a cubic, right? D is a cubic. Okay. So which one would be my answer then? Hmm? Let's see. C. So if I find the derivative of C, right? So if I find the derivative of C, the derivative would be X, right? So when if I were to make a slope field for X, would that give me something that looked like that? That's my question. That's what I'm looking for. So figure out which one it is. Figure out which one it is. Okay. Mhm. Yeah, I'm thinking E. I'm thinking it would be E because if I found the derivative of E, that would be to the third power. It would just be on the bottom, right? I'm thinking E. Yeah. This one's a little different. Most of them, they will give you the derivative. They'll already give you the derivative, kind of like the bottom, the last slide. This is more in line with what they'll give you. They've already done the derivative part. You just have to match them with what they have. So there's 6 of them and 6 graphs. Okay? I want you to work on the last 9-10 minutes of class. I want you to work on this. Okay? This is what we're going to be doing tomorrow. We're going to be doing a little activity tomorrow. We're not going to be doing any new notes. We're going to be doing a little activity tomorrow. It's a matching activity. And it's going to look similar to this. So that's why I put this last, because this is going to be what you're going to see tomorrow. Okay? So it's a good practice for it. Okay? So I want you to work on this the last, like I said, 9-10 minutes of class. And then we'll talk about it tomorrow first thing. Okay? Try to match them. You can only match one with one. So once one's been used, no more. You can't use it anymore. Okay? Each one can only be used once.